So the next step for us to make, the next set of features to consider is to address the idea of set date to be handled somewhat different. Would be nice actually to be able to do it this way. Would be nice to do it this way. Why wait for the next line if we know that we want to create the date and provide known values, right? So this is our next step. But before I go this way, just a few observations that I want to make. Observation number one, we added class date to our code. Somewhere this declaration appears to be in our source files and the header files, and the compiler eventually sees it. So what compiler does with this declaration of class date, it doesn't have any executable code. It simply is placed in the header file. Remember, header files should never have any executable code. So what it does, it simply looks at this definition or declaration of the class and says, okay, there will be a new class named date. Class determines new data type, and you can see you can create variables by using the name of the class. It knows that the size of this object in memory is going to be the size of this integer, because of course it needs to store the integer serial date in computer memory when this date is created and created in the scope of function main. I want to make an observation that adding member functions to the class does not change the size of this object. It's very important. Therefore, if I added 100 new functions to this class, it still would take just the space of one integer in computer memory. This is really good, and it should be observed. This is due to the internal structure of the program, that all executable code is placed in a separate memory segment, and all data, including member variables of our classes, are placed in the data segment, and therefore functions and data actually live in separate memory segments, and function definitions don't change from object to object. So therefore, there is no need to allocate new space for member functions with each object. Only the data changes, but the functions remain exactly the same. So every object that we create gets access to exact same set of functions when the member functions execute. It's just a technicality I wanted to mention. The bottom line is the size of this object is defined by the list of member variables that are placed inside the definition, and not by the list of member functions, right? So it's free and it's easy to add new member functions to an existing class, and it does not affect the size of an object. The size of an object, of course, is important when you create thousands of objects in computer memory, right? So if we're reckless and create too many objects, we may run out of computer memory. So we need to worry about the sizes of our objects in general. But just good to know that member functions do not contribute to the size of an object. Only those things that we place as member variables inside the class contribute to the size of an object, because they're obviously storing physical values. Right? Placement of member variables and functions really is not that important. I think in our textbook, the convention is that the data is typically placed over here at the bottom of the class definition. Right, so it's just the idea is to give more visibility to the member functions. So the placement of this is unimportant. It can be down in the bottom, it can be up here at the top of the class. My personal preference is to keep the member variables at the top, because they really define the size of my object, and that's what I really like to see when I open the class definition. conventionally in textbook, this is how it's done. In the textbook, the member variables are typically placed at the bottom of the class definition. Another observation I would like to make is that this class, the presence of this class in our code, this declaration, does not create any objects. We have to create these objects like this, then the object is created. By simply having class in somewhere in the source code, no objects are created. It simply is just a definition of the data type, which we called a user data type, user-defined data. So let's now go ahead and address the issue that set date is a good idea to have, but we would like to be able to do it also this way. Just like I said, we would like to be able to add this date, like to be able to provide initial values right from the start. And in order to do this, we need to define constructors. Constructors are member functions, but they're invoked automatically when the object is instantiated. When the object is created, the constructors are invoked. Because we want to be able to construct our object without restriction, just like normal variable. Most of the time, constructors are considered to be public functions. So I'll say public over here. And constructors are recognized by the fact that their name is the same as the name of the class. This is constructor. Once we gave our class a name, from this point on, its name, if it appears inside the class definition, is recognized as the name of the constructor function. In my case, of course, the sigma of this constructor is the same as the set date. That's what I want my constructor to do, to be able to accept month, day, and year. Semicolon, right? So this is a declaration of the constructor. Special function, which is responsible for initializing my class date with initial setting, initial month, day, and year. So this is the implementation file for this class that was placed here in this file. So of course I will do the same thing. I will copy my constructor and I can paste it anywhere I want. How about I just put it right here and I say these are my constructors. We can have multiple constructors. That's why I use plural constructors. Okay, and so of course in the implementation file, which is the CPP file, I will replace the semicolon immediately, giving it a body. Then once I do that, what I could do, I could simply call set date, which is my member function, with these values. Constructor takes month, day, and year, and now I know that I have my member function set date, which I will call. Take a call into this function, set date, and you know that this function is already being implemented, and it sets the serial date to a specific value. Right, so it's already being done. So internally, my constructor invokes a function to do the work and take care of the whole configuration of this object. So now if I go to serial date, to my main file, I no longer have to have this line, right? I can just get rid of this line and create my date by passing the set of initial parameters. Let's just make sure that it all is working correctly. So once again, this is the change that took place in the header file, which provides declaration of class date. We added comment that says constructors. we added date constructor, a specific constructor that takes 3 integers corresponding to month, day, and year. Then we add a definition of the constructor to our implementation file for this specific class. And one only observation is that what I typically forget to do is that constructor is just another member function inside this class, just like these functions. And therefore, I need to prefix its name by the name of the class. So it looks a little weird, but this is how constructor implementation looks like in C++. It just says date, date, driver license, person, person, and the double colon in the middle is a scope resolution operator. Basically, it says date is a constructor inside the scope of class named date. And that's how constructors look like. So with this change, I decided to get rid of set date inside my main CPP and simply set date, this is the name of the object, and pass the values. All right, so let's build this. And run it very quickly. Right here, you see that it's still working. It does pretty much the same thing with our with my mockup, where you know that in reality these functions should do something real, but I just, for the serial date, I return 0. For month, day, and year, I just have this hard coding 12/31/2019. That's all I have.